Hi everybody, good morning. This new room event horizon. Unearth the secrets beyond event horizon. It was released Friday. Join Tom and Dom on quest to find out what happened when you look beyond the event horizon. A quest beyond border. They need you to utilize all your ability to find the secrets that were taken when they crossed over the other side. This is a Wireshark, a similar room in TryHackMe are getting C2, so this is another, it's a new C2. Um, and me microphone. Okay, let's see what we have. When you download the files, you get this evidence. You have this is when I was trying. You have a PowerShell. This is a dump file, a memory dump. It's not a Wireshark. And then they have traffic, so we have traffic and we have memory dump. So what's inside this file? What I was doing this weekend. Um, okay, so let's start. Sorry, let's start with Wireshark. Now, as always, when you're stuck in Wireshark, it's better to know what's going on. You can see from the conversation, most of them 7 meg running between these two IPs, 10.02.45, 10.02.46. So the rest you can say safely ignore it. There's a lot of traffic happening here between these two IPs. You see one is the target, one is the hacker. Sorry. Also you can do protocol give you also idea what's going on. Remember the first question said you attacker was able to find the username and password for the email. You can see here the simple mail transfer protocol, SMTP, and you have POP, the post office protocol. So we can see there is the mail for the first question. What was the second question? Also by regarding the email, and then the command JPEG file intentions format. Okay, interesting. With the big data through HTTP protocol, we have how many we have? 1,000. There we have the mail. We have also the mail. UDP. What's this? This is part of the whole traffic. So the first one it talk about SMTP. So you can go SMTP, and you can go SMTP or POP. So you can see what traffic related to emails. And then of course when you go now to these things, you can see, if you just go there, you can see already start. Let's start from the top. You can see it start pop 3, and you can see it's already doing here. Send your password, the testing username invalid, things like that. So you can just follow one of them. For example, follow TCP stream. If I follow pop3, said start with user and said password clear text invalid, looking for the one, and all of them basically, this like the first session, the follow one, all of this is all invalid, so it means it must be another session somewhere. So let's go back to our pop conversion. So if you scroll well, it's still invalid. If you go down, suddenly that's the invalid change, and there's something new here. If you go back to, I put the info here for where is the new yeah, you can see in here after last invalid username and password is another. This is ESMTP. This one is an enhanced version of SMTP that require authentication to send and receive, I think. So this one, if I follow, you can see this one it give you, because somehow authentication log, then suddenly is base 64 authenticated, so it must be this one. So if follow TCP, you can see it, and that's basically you get the answer. Because if you convert this from base 64, they are base 64 converted, use cyberchef or something, you will get username and password. Because this one, for example, if you go this, what is this, if I go to my we come back to do, for example, just echo base 64 minus d. So this is, it asks for username, so it's everything is in base 64. You can convert all of them from base 64. You find username and password, and then the next question is the body email. You can see the email order you get is from tom@event.horizon.hackme. We have the message, and then we have this little base 64 too, so we can just take this one and see what exactly this one is. We can go in the same things, echo that one, base 64 minus d, and then we have something interested here. So we have constant G6 wherever, a gravitational constant. Oh, that's why the room is called that one. Speed of light solar 1.9, and then function to calculate the Schwarzschild radius of a black hole. Okay, so we have that function to calculate the mass of the black hole given its radius function. So do something else, and then given the radius whatever, calculate the mass of the black hole. This is a, what is this, a PowerShell. Right, no, it's not. Yeah, it's a PowerShell. Write output the mass of the black hole, and then write output in kilogram. This is approximately black hole mass in kg, and then suddenly we have this thing. So it's a PowerShell download this string, and this is exactly this is the question for what's the download the user use this. If you go back to the email, let's go back to the email quickly. It said this is a what? Tom, I have done it. I have found a massive black hole. Black hole. We found. Run this script as administrator. Your best friend DOM. So basically here you can see the scenario how it starts. The attacker or something send the script to discuss as calculated the mass of black hole, because if you start it look legit, it's just doing some couple of math black hole, but later on, and now we know, see this IP, the 45 is the attacker IP, so the person doesn't notice, he noticed that, oh, it's a normal script, but at the end you can get is down on the script. So we need to know where is this script from. So we know the story, what happened. So they send an email, so the attacker hacked the email. So the person hacked the email because he found the password, then send an internal email because he got the email. He sent it to Don Mark and then tell him, oh, we found how to calculate the black hole, but he hide the script that is downloading the malicious script. Now we know it's downloading, so it would be get request. So we can go to, yeah, you can no, not this one, come back later. You can find it easy with the http request method. Method, we can say get, and you can see because it's get, you can see this is the one that it start for the website, images, favicon, index.html, this is doc.html things. I'm not sure no, we're not why we don't see that radius things. Image, yes, that's the radius one, so we can see the radius. If I follow HTTP request, it look like this. Okay, so it's a base 64 and also it's a new object, so it's in memory. So we need to find this, or we can just do this. We can just go to file, export object HTTP, and because we know the name of it, so it's a PS radius PS. We can save it. TryHackMe event horizon. Okay, so we save it. Where is it now? Hello. No, event horizon should be radius. Open it. So we have, this is the radius. So basically you can see it's from base 64 streaming the memory. I'm not a very good Windows, but then there's these little things there for compression and things like that. Yeah, you can get ChatGPT when you want to reverse it for you, and then we'll use this script to reconstruct it. So basically for zlib, because it's compressed, so this is the data we got from this radius. So this is the data. So this is a Python script that will compress the data base64, decompress it with the zlib for deflate, something like that. I'm not really 100% of this, but it's fine. We can go now to who is this? Now we go to the description there. So let's open. Let's leave that one there. So we have Python 3, the reconstruction binary. So now if we run that thing, so we'll get a new file, the file, this one. So if I do file reconstructed binary, you can see it's a PE32 executable Intel mono.NET. So it's a .NET for MS Windows. Your next move is SHA to file, for example, reconstruct. Now the next thing, you can just go and say what is this binary. You can go to our friend will search for it, and he said it's malicious. You go detail, he said this one is okay. External assembly, okay, nothing. Let's go to next tab, relation. Oh, it has some IP, one connected domain, 2 billion file, drop a file, contact IPs, behavior, communication, data manipulation, HTTP request, connect to this IP through port 8081. You can see the test. We saw these test things when we did the GET request before. There is some test things here happening. This index, this is a test file here, so we come back to them later just now, so we know there's a test.html something. The IPs, the 81, this the IP traffic, and then evil, what evil? A process tree. And then if you go to the comment, we get our break. The break come here. When you go to this, you can see it not in this comment. Covenant launcher. And then also this one, it tell you detect Covenant stager. Covenant, if you Google it, it's basically this one. Covenant is now this one. It's basically is a C2 in .NET. So we have a C2, we have traffic. So if you go back to our friend Wireshark, remember we talked about this, because if you look, for example, there was a download of radios.ps1, then there is this TS2. This, if I follow HTTP stream for this, strangely enough, these very things, this hello world, and then things that be interesting, you see I equal, and then we have data equal. It look like it's a base 64, and we have a session. So if I copy this, for example, and if I go to what exactly this will give me, if I go there, and then it's a base 64, and if I make it bigger, It's a GUID, some number, type 0, meta, we have an IV, and that's why the room talk about the key IS of the IV. We have an encrypted message, and we have HMAC. So we know it's IS, but we don't have a key. Now if we follow Wireshark, you can see it has that, and then the response come like that, which is base 64. If we try that and we say yeah, this one is a response. We have type 1, so this is type 1, the other one was type 0. If we take, for example, another one, for example this one, so it is type 1, type 0. It's always giving me the IV, it giving the encrypted message, and don't have, and it keep running the same things. And then the response always start with hello world, and then the response, it's straightforward base 64. It's not like when the server sent. The response is like that, is type 1, and then but when it send it as I equal, and then put data equal. So we have and then we have this. You assume one of them is the flag, and then the last question, then the other question for the NTLM hash for the user. So we have the traffic. Now we need to decrypt it. So before we go there, because remember we got this one, we said it's a PE32, it's a .NET. So if it's .NET, I can transfer it already to my machine. So if I go, for example, to my Windows machine, I can use ILS Pi. If you have it in your machine, for example, I can open the file that we do to desktop. I just call it binary. You can just open it. Where is what we call it? Reconstructed. RS reconstruct. This is the PowerShell I was playing with it. Reconstructed binary. If I open this, why? I thought I switched it off. Yeah, this is my VM, so if you open it, what's your problem now? So if you go to the metadata, is nothing. A reference. Look in metadata, if you go string hip, you can see here, you can see the key somewhere here. You can see the GUID. You can see how that's a key. Let me make this one. How to get this one bigger? Let's go in with this Microsoft. Why I did switch you off. I don't need antivirus. Off. Firewall network. We can trust. We can trust TryHackMe for a day. Okay, let's open it again. Don't tell me now that something went. Where is the file? Microsoft did remove it. This stupid antivirus. Why you removed it? need to copy it again. Guys, give me a second. I don't know where is the file. Let me pause a little bit. Hi guys, I copy again the binary because this antivirus problem. So I said, well, if you open it, you can see the header, you can see the what you can see the string hip. If you look, you can find the string of the key. You can see all of that. Let's go quickly before to the gangstar. This one, this part here, you can see all the data. This is the main one that contain all the information we're looking for. Where is the one for the key? With the key we need it for decryption. Where is it? Yeah, you can see is calling, that's the hacker. We have 881 port. We have the format. You can see if you go to Wireshark, you can see it start with this. Then we have this number, the GUI ID 520. We can see it. Where is it? 520. You see it there when you why it's AAA. Let me get another one because look me strange. Where is the session? Control C. The GUID 553 triple A. Oh, that's the 20. It's I'm confused. Where is that machine? The virtual box. It's 520, 6E520, 6E520. Let's go to Wireshark. See, it mean it start with this as prefix, then you have a random number there. We have type 0, type 1, and we can see them in the script. Where are you? Virtual box. You can see the ID, then some random characters, and then this one, for example, type 1. And you can see the key, the first one, yeah, because the key, it is stages. The first key, the key is for stage 0. So we can get this key. So we need this. Let's copy it before our antivirus. So we have the first key now. But what happened here? What? Where are you gone? That first key is for stage 0, but later on there's another key get generated for stage 1. So this key doesn't decrypt the whole thing. It's only for stage 0. To confirm that, let's see if we have a stage 0. We have stage 0 data, this one. So let's copy that data. I will show you how stage 0, that key work for stage 0. We can copy this data. We can put that there. And it's from base 64, not base 68, base 64. From base... this is stage 0. And then we can get IS decrypt. And then we got the key, this one. I can cut the keys base 64. We have the IV for stage 0. You can see type 0. We can get the IVs. This one. It's also 64-bit. So the key, the IV is 64-bit. The input is not hex. It's raw. And you can see it was decrypted. So we've been able to decrypt the first stage, this one, the stage 0. Type 0, you can decrypt it. And you can see RSA, key value, modulus, U. So basically we got the modulus of the first, for the private key. So we have RSA key value. So we got something. Doing it manually is a problematic, but if you follow the story here, Where's stage 1, stage 2, that story? I forgot where they are. Uh, where's stage 2? No, I can't lie to you. I'm getting confused now. This type 1, type 2 things. Yeah, that's how we do the math, how we do the encryption, because we already have the Wireshark. We can take no, not the bigger one. Let's take this one is the, I think is the where the flag is. Let's not go to the bigger one. This is stage 0, so this one should be a response. And then if we take, for example, this I data, this should be type 1. Let's see if this is type 1. Type 1 is this, let's see, this is type 2. So this is type 2 and type 1, and we need a key. So the first key, the key that we found, the key that we found in the machine, this key, is only for type 0. And then it gets used later on. This key, not you. This one is for type 0. That's why it's type 0, and that's why we've been able to get the RSA key. We got the modulus. You can see we got the modulus. Now, if you Google and start searching, you can find this is the governance. And then if you Google, you find this governance decryptor. They already give us decrypt governance traffic and extract private key. And if you go down, it tell you the modulus. We already got the modulus. This is his hex. We already have the modulus. We got it. This is the modulus. It's a base 64. I can, for example, push it there. Base 64. From base 64, convert it to hex, for example, and then no spaces. Let's confirm later on if this is what's the modulus that script get. Let's use the script. Now, if you download the script, we only need. Let's be clear. There's a requirement you need to install. You need to just click Markdown here this. So you need to install these things in your computer. Be pipe3 install rich type extension. You need to install all of this. So for the script to work, I already installed them. I'm running in virtual machine. As I come back here, so we have this. Let me leave that one. Let me do. I have the lab. So I go Python virtual. So I have lab binary source. Binary activate. So we have these two scripts. So let's follow the instruction of these things. So the first one is, before we jump, is getting the modulus. So the first one is modulus minus I traffic. Now where we get the traffic from? Now we already got it now in Wireshark, this one. So we can just save this, but this some things we need to think about it now. Let's call it like is what is calling it traffic.txt. No, let's call it traffic 0 because I just call it traffic.txt. So if I follow this these things, I'm getting confused. So what's wrong with you? -k, we get the key, we have the key. Where is that key? Then what next? You give it the key and then -t base 64, -t base 64, and then you start having trouble. I tell you data parameter not found because it's the way you get data. Now what we can do, basically the idea is you need to remove all of this this HTML, only leave this and the response is this, the base 64. So we need to remove all of this. Now we can play with it. I think there is we can just do grep for this. So because I'm looking for I equal and wherever I ended the hello. So let's do that. So if I go now to my not you, why I didn't copy. Let's get one because I couldn't remember them. Copy. So I can come here and say the traffic file, and then we can just call it govern. What's the name of this software again? C2. Let's call it c2.txt. Let's confirm that it's working. And you can see we got the first one is, let's make sure with Wireshark are we getting the correct one. This is Wireshark, so we have EY, yeah, that's one. The response is EYJH, so we got all of them. So we have all the data we're looking for. Ctrl G, close. So now we have the file. So let's do that modulus again and see if we don't have problem. Let me make it bigger. Where is that modulus again? Am I in the same this function? Now we have a new file. Let me change the name of the file because now we did a combination. We can just reuse that C2 now. C2.txt space. Now we have a modulus. We got 2, 3. Let's see if we got the same thing as when we did that one. It's not the same modulus. Really? This one starts with 23598. The 65, that one is fine because this let me see, this value, this is the modulus. What it's supposed to be 65. I think I'm not getting it right. It's not hex. From base 64. No, this is decryption. This is base 64. Modulus is this. So what type of this is the exponent AQAB, which is supposed to be that. So I'm not sure. From base 64. I don't know why it's not the same. 235. Wait, this must be base 64, so not to hex, to decimal. Two five. I don't know. Because this is decimal, so it's supposed to be something related to decimal. Why am I getting confused now? The easy way to get these little things. but we need to say from where. I forgot, guys. It's a decimal. I don't know. Let's follow the script. I thought we can do it here manually because it gives us the modulus, but I forgot what it is. In any case, I forgot about it. So let's copy this, the modulus. Let me, because there's space on them, the break-in one. So let me remove the break-in. Yeah, because this is decimal. So if I put this in Wireshark, what exactly will do? From decimal. Okay, let's get, I don't want to waste time for this. Line feed. Any case, let's not waste time. At least we got something there. The key. Any case, let's follow the script. So far after we got the modulus, we go to encrypt extract private key, and then that's where we got that memory things. The PowerShell memory. PowerShell memory. Mine is in evidence. PowerShell. Temp, the demp file that they give us from PowerShell, and then after we give it the demp, we do -m the modulus, -m, and then we give the modulus. Where is my modulus? This one. After you remove that the break-in line, so you put it in one command, and then minus the modulus, and then what we do? -L, and then the keys. Do I have a folder for my keys? Let's create a folder called keys. No, not there, not you. This is something else. Create a folder called keys here, and then -O, the keys. -O, my key folder. We do that error for whatever reason. If I do the keys, I have the private key there. So that's the key that we're supposed to get it using this. And then the next step, after we create the key, you can see we create a key. This script will try to get P and Q as little as big Indian, and then recover the session info from stage 0 response of a covent C2, which is employed to decrypt the network traffic. Now we can do this. Remember, not you. Then the next one is, remember, our C2 file that we combine the traffic, my C2. You give it we got the memory, now we got a session. So decrypt the key -I -I the traffic. I don't know why is dash key. Which key we need to give? The one we did before, the key. So we can go there. And then -t base 64, -t base 64, and then we need to give it -r the key. -r the key is in my key table, so we have that. -s1, it's going to stage 1, so type 1, and now it gave me the key. So I have the new key that I'm supposed to use. Now because I have the key now, you can do automatic, or you can go backward. You can see, for example, now I have the key for stage 2. So I can take, so for example, no, this is too big for me. Let's take, for example, this one. If I go to there, so we have encrypted message now is this one. I can take, for example, that, close you. This is my encrypted message, and then let's see if it does work. It's a base 64, so we need to go to from base 64, base. No, we all from base 64. Then I have IS decrypt. Now we have the key. Let's see if that key work. This one is hex key, so you can copy that. It's a hex. Then the IV for this is this one. It's a base 64, so we can use that one. Base 64. IV is base 64. Input, it's raw. Huh, didn't work. What's this funny character here? Let's get something nicer. Let's get this one, bigger one. Otherwise we do the automatic script. It's good to play around. The IV is this one. The message. Oh, the encryption, it looks like it doesn't want to work. The manual one. What, we need a bigger one. Let's get a bigger one. Oops. Let's take this bigger line. Let's see what this big line will give me. Not you. Not there. The encrypt message is this one. Let's do. This is a big line. I mean, there's no one small. Let's see. I don't know. It's like I don't know why suddenly it doesn't work. Data equal. That's a big one. Too much running, scrolling down. So the message is. So if I go, will the key change by the way? Enable to decrypt. Oh, the key. I messed up the key. The key is not that. It's this one. Oh, now something is running nicely. Now let's get the IV. I was pasting in the wrong place. Now we find something around integrity 3, process, PowerShell, user domain name, event horizon, username administrator, delay 5, JETA. So we can see it decrypt. So we have the correct key. So we have the correct key now. So let's go to automatic now. Let's go to automatic. The next one is, if we want to decrypt now the communication, we use this one, -I. Oh, that one is for the next one. We have the -I, the traffic is C2, our file. Then what I should give it, the minus key is the new key that we found, this one. Minus key. What else we give it? Minus T hex 2. You say we go into the next, because 0 is the first key, and then 1 and 2. Let's see if this one, no, this one it decrypt the whole thing. You can see it's getting me all this base 64. Let's do this. Let's redirect it to let's say call it C2 command. This is the attacker commands.txt. So if I go to C2 command.txt, now you can see, oh, that's what we've been seeing before. That's fine. It's not like it's not working. That's how it was the response. So we have message 537.911. We have here, we'll see, you will find the NTLM hash for the user. You can look for it. This is Mimikatsi. You can see the Mimikatsi. And then we have output system2. We have output IV things. And if you go on, you can see it's all the file. It's a base 64. So basically we can get the NTLM hash from the beginning, but then we have all this base 64 data. Yeah, you can do it in different ways. So you can be lazy where you can just do this. You can just delete the line that you don't need. For example, if you don't want to go fancy about it, and then you can delete that. So you can just keep the data. If you don't want to be fancy, you can just do that. G, you go at the end, close that one, remove that. I can do this, for example, and I have a base 64 data. You can do this, and you can just say cat C2 and a command, and then you pipe it to base 64 minus D. And then what? And then, for example, assuming is a flag dot, let's call it C2 flag dot binary. And then if I go to file C2 flag binary, it tell me is a PNG image. So basically, you can just move C2 flag wherever to C2 flag and call it PNG, and not you. Do C2, for example, flag.png, and you open it, and you can when you open it, it will be like that. The flag is in the bottom. I'm not showing it. You'll see an image like that. You can flag.png, you open it and you see it. Remember, this one we did a delete, or we can do this if you don't want to do that. For example, now if I want to go back to my message, that's the C2 command. So if I want just to get the data, let me show you quickly something about this. If you want to use a grep command to extract the data for you quickly, you can do this. So if you want just to add the base 64 data, and I don't need this one, I can use this grep command, grep this, because status to output, I can use this command. I can paste that from the C2 data, push it to base 64, because base 64 minus D, and then call it my flag dot binary. So we just did without deleting manually. Oh, what happened? What? Why is it invalid input? Okay, let's do it in two stages. Let's call it there local my data txt. So now we got my data.txt, we got the base64, we can just say my data. Now I grabbed base 64 minus t, then got my flag dot binary. What's wrong with you? Because of the last line. Okay, let's find my file, my flag.binary. Yeah, it's a PNG. So basically, yeah, so you can just delete line by line or extract it. I don't know where that line, that space came from. Yeah, and then you get the image has the flag in the bottom. So to recap the story is a user sent an email, was able to get get access through, remember we did that SMTP things, SMTP pop. So the user got cracked the password, so he got a password, and he got send an email to, because he was able to enter the email, send an email to Tom and send him this script, like to say calculate the mass of black hole, all of that. But then he download a binary, a PowerShell script radius.ps1, and that radius ps1 is in fact is it's a governant binary. And then when that was installed, it start sending data, and of course, and we can use this script to run it. I thought to use it manually, but yeah, the problem of manually is how to get this key, because I don't know, this module I forgot. It's from decimal or something. I need to check that one later on. But basically, yeah, guys, this is the file. Thank you very much, and yeah, hope you like it. Please like and share, subscribe, and thank you very much. Have a good day.